Hello, all you geometry students. Today we are going to continue our learning with factoring trinomials. This time we're going to add one more step. So yesterday you learned how to factor trinomial by solving the sum and product puzzle, making two binomials out of the sum and the product puzzle answers. Today we are going to add a step that goes before those steps, and that's taking out a GCF if there is one. So when all three terms have something you can divide by, we're going to take that out before we even begin. So let's see what that looks like. Okay, so for this first one, what do you notice can come out of 3, 21, and 30? If you said 3, good job. So we can divide them all by 3. Let's do that. Let's divide each one of these terms by 3. So I'm going to pull the 3 that we divided them by outside of the parentheses, and then inside the parentheses, I'm going to leave all 3 of my terms, but after I've divided by 3. So when I divide the first term by 3, I get r squared. When I divide the second term by 3, I get 7r. And when I divide the last term by 3, I get 10. Now, this 3 on the outside, I'm going to ignore it for a while. I'm going to bring it back at the end. But now I'm just going to look at this trinomial, and I'm going to factor that trinomial just like we learned yesterday. So a review of yesterday, remember that this 7 is what the numbers add to. It's the sum, and the 10 is the product of the two numbers. So it's just like solving a sum and product puzzle. I like to take my product, 10, and I like to list out the factors of 10 until I find one that works for 7. So I start with 1 times 10. Those do not add to 7, so I'm going to keep looking. 2 times 5, those do add to 7, so I'm going to keep them. So I'm going to write r plus 2 times r plus 5, and I'm almost done. So yesterday we would say done, and we would be finished, okay? But today we had pulled this 3 out, right? And so we need to put the 3 back. So what we're going to do is we're just going to write these two answers together. We're going to put our 3 with our r plus 2 times r plus 5. And if I were to multiply this out, you could do it in any order. I'm going to FOIL it first. R times r is r squared. R times 5 is 5r. 2 times r is 2r. And 2 times 5 is 10. And then I'm going to take this 3 and I'm going to multiply it across all of these terms. And I get 3r squared. I get 15r. I get 6r. And I get 30. When you put these two together, I now have 3r squared plus 21r plus 30, which is exactly what I started with up here. So I can always check and go back with my work. All right, let's try the next one. Do you notice a number that can be divided by each one of these terms? Did you say 2? Good job. Divide each one by 2. When I divide them each by 2, I have pulled that 2 out, and now I have p squared plus 7p plus 12. Okay, again, this is my sum, this is my product. So I'm saying what multiplies to be 12 and adds to be 7. So again, it's nice to just lay it out here. 1 times 12 does not add to 7. 2 times 6 does not add to 7. 3 times 4, ding, 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 adds to be 7. So I'm going to write my two binomials as p plus 3 and p plus 4. Bring that 2 down and place it in front, and that's my answer. If you want to, go ahead and check it. I feel like we did a good job. Let's move on. Okay, looking at this next one, what do you see we can divide by? Is that 2 that you said? Oh, awesome. You can divide by 2. Okay, when I pull a 2 out of all of these, I first have the 2 on the outside. Okay, now I have r squared minus 8r. Don't forget when you have a minus to keep that minus in there. Plus 15. All right, so again, this is my sum. Remember, that's -8, and my product is 15. So first I'm going to make my little list of factors, 1 times 15. Remember when this number over here is negative and this number is positive, that means that we have probably a negative combination because a negative times a negative equals a positive. So we can put negative and negative on there, but we'll just know that maybe I shouldn't say it that way. When I see that negative, I'm still looking for an 8, but remember that I'm combining them to make negative 8, so I just have to put negatives on both. Let's try the next one. 3 times 5. Does that make 8? It sure does, but to make it make negative 8, I have to go negative, negative, and that will make negative 8. All right, so I'm going to say r minus 3 times r minus 5, and again, that 2 goes down in front. All right, the next one, what can I divide by? Oh, 3, that's right. Let's divide it by 3. So again, the 3 comes on the outside. I have n squared as my first term. Negative 9 divided by 3 is negative 3n. And 6 divided by 3 is 2. All right, so what multiplies to be 2 and adds to 3? Well, the only thing that could work, because it's prime, is 1 times 2. And it does equal 3, but it doesn't equal negative 3. So how can I make it equal negative 3? A negative and a negative. Negative times a negative is a positive. Negative plus the negative makes a negative 3. Okay, so we've got 3. And then n minus 1 and n minus 2. Done. Let's do 2 more problems. All right, I bet you see it already. What can we divide by? That's right, we can divide by 3 again. When I do, I pull that 3 down, and I have b squared minus b. Remember, there's a 1 there, a 1b, minus 12. Okay, what multiplies to be negative 12? So technically, this is a negative 12, and adds to be negative 1, because this is like a negative 1. So we know we're looking for 2 numbers that are right next to each other. So I've got 1 times 12, that won't work. 2 times 6, that won't work. 3 times 4, that one's going to be my ticket right here, because I know that when 2 numbers are 1 apart, that they're going to add or subtract, or they're going to subtract to be a 1. So which one of these has to be a negative in order to make it be add together to make negative 1? That's right, it's the 4. So if I put negative 4 and 3 together, I'll end up with a negative 1 as a result. If I take 3 times negative 4, that would give me a negative 12. So I'm going to go ahead and bring my 3 down, bring the 3 down, and I'm going to write b plus 3 and b minus 4. And we're done. The last one. I notice a 2. Did you see that 2 that could come out of all of these? They're all even numbers. So I'm going to pull that 2 out, and I'll divide by 2 to get n squared. Divide by 2 to get n, or remember that's 1n, and divide by 2 and get negative 6. Again, I'm going to need numbers that are right next to each other. So I'm probably not going to work with 1 times 6, because when the difference of those is 5, right? But 2 times 3, that difference is 1. But I need them to multiply to be a negative 6. So one of these two has to be negative. But I want to result in a positive 1. So which number needs to be negative in order to have, when we combine them, for there to be a positive 1 as a result? That's right. It's the 2. We want to put the negative on the 2 because negative 2 plus 3 makes a positive 1, and negative 2 times 3 makes a negative 6. So again, I'm going to bring this 2. It's just kind of going to hang out all the way down. And then I've got n minus 2 and n plus 3. Remember that you can check every single one of these if you want to as you go. Good luck. Have a good day. Bye-bye.